This video shows you how to reduce the time it takes to test a whole lot of printed circuit boards. This is accomplished by using a test application to effectively do the steps in the test procedure that might be done manually, and a test fixture which allows for pogo pins to connect to parts of the board to interact with the board, and that same test fixture connects to the instrumentation which is used to run it. Hi, I'm Paul Phillips of Phillips Engineering. My love of engineering began as a child and continues through today. Now I get to share my passion with you. Hopefully you'll find some of my projects interesting and valuable. So, grab your favorite beverage and let's go. There are three main steps: getting information from the customer, doing the work, and delivering the product to the customer. The first step involves getting information from the customer. This is the preparation stage. You'll want to get the manufacturing files such as Gerber and Exelon. This will tell you where the positions of all the different items are on the board. You'll need this for when you create the test fixture, because that will tell you where to place like the pogo pins so that they touch the points on the board to be tested. You'll probably want to get the schematic, because sometimes the schematic will tell you information that is, if there's a question about something, it can help clarify things. You'll need the bill of materials. The bill of materials will tell you the actual part numbers of the components. And so if you need to know something about a particular component and you need a data sheet for that component, you'll have that information. You may also need a list of required software. Sometimes there might be EEPROMs to program other things, and you'll need that information from the customer. You'll also need the test procedure. The test procedure is the document that tells you what you do step by step to test this board, and very importantly, the acceptance criteria, which tells you if that step passes. You'll need a list of required test equipment. If the customer is providing the test equipment, you'll need to know the specific models of it so that you can probably write your programs for it. You'll also need the list of deliverables. The deliverables meaning perhaps it might be the test fixture, like bill of materials, manufacturing documents, things like that, whether you include the software for the application, the source code. One thing that helps a lot is if you have an example of the board, a physical example in your hand, because much can be told by having it in your hand that can't be expressed in documentations very often. And once you have all this information, there's likely going to be some kind of questions you have, some clarification you may need, and that's when it's time to get in contact with the customer and talk to them about clearing up any misunderstandings. And then once you have all that information, you're prepared to give the customer a quote. The second step involves doing the work. Now it's time to create a skeleton application. This won't have the specific functionality to make the test work, but it'll have functions named according to the test procedure. This helps to correlate the test procedure to the test application. If the quote includes you providing the test equipment, then now's the time to order it for rental or for purchase, depending on the customer's requirements. This can take some time to get multiple quotes, so you may want to get the quotes, put the bid in for quotes, and start thinking about your next steps. You can create a test fixture now at this point, so that you can, because that will be the board that will interface with the device to be tested, including locations of pogo pins and such. It's also now very important to consider how you are going to physically contact the board. Are there points of access at the bottom of the board? So that means you may want to have pogo pins. Do you need to look at some topside access? Are they connectors? You have to consider how you're physically going to touch the board in order to interact with it. And once you have the test fixture, you will have you may very well have a bill of materials for that one. So now it's time to start thinking about that. And when you create your test fixture, the bill of materials for that one may not include such things as rubber bumpers at the bottom, connectors, alignment pins, and such like that. You'll have to add that separately. And now you'll have a bill of materials for the test fixture. Now it's time to place the order to have the test fixture manufactured. And now it's also time to have to order the components, if any, that are needed for the test fixture. Now, while you're waiting for all this stuff to happen, you have time to fully implement the test application. So you're gonna, now that you know the equipment to talk to, and you know how to talk to it, you have documentation for that. Then you implement that code into the test procedure, so you'll actually be able to really do things, not just say I'm setting up a power supply, but you're going to say set power supply to 5 volts, and you use the actual commands necessary to do such a thing. When the board arrives, now it's time to assemble the test fixture, where you may have to solder some things, add connectors, things like that. And now it's time to test the boards that the customer wants tested. The third step is after the product is completed. Now it's time to settle payment for the customer and to deliver the deliverables to the customer. That's all it is, just a few steps. Have a nice day.